All right, let's look at a proof and see how we can apply these theorems and converses to a proof. When I look at this one, my first given is line R is parallel to line S. When I look at my picture, I can see it's already marked for me in the picture. I like that. Then the measure of angle 3 is equal to 7x minus 32. Given. That's not marked for me in the picture, so I'm going to go ahead and mark that. 7x minus 32 is angle 3. Okay? The measure of angle 5 is 3x plus 12. And that is also given to me. It's not marked in the picture, so I'm going to mark it in the picture. Because now what I need to do is I need to determine what's the relationship between 3 and 5. Are they vertical? Are they linear pairs? Are they alternate exterior, corresponding, alternate interior, same side interior? What are they? Okay, so I know they're not vertical or linear pairs because they're at two different intersections. So corresponding would mean they're both in the same direction. They're not. Alternate exterior means they're on the outside of my two lines. They're not. They're both on the inside of these two parallel lines. So they're either same side or alternate. They're both on the left, so they are same side interior angles. Which I know that if I have parallel lines, which I do because it's given to me, then my same side interior angles are supplementary. Now I can't just jump ahead and say add these together and make them 180. I have to put all that information that I just said out loud in the proof because I'm not going to be there necessarily when someone goes to look and see how did I figure out that this was 72? How did I know that these have to add together to make 180? Well, first, because I knew that these were same side interior angles by looking at the picture. So angle 3 and angle 5 are same side, I'm going to abbreviate, interior angles. And how did I know that? Because it was given to me by the picture. Okay, and you don't have to write by picture, but that way when you're looking back at it, you can kind of go, well, it's not written in the givens. How did I know that, right? Just kind of remember how we got that, okay? So now you might be thinking, okay, now that we've said that they're same side interior, now I can do this plus this equals 180. But how do you know they equal 180 just because they're same side interior? We know they equal 180 because when I have same side interior angles and parallel lines, then I know I have supplementary angles, right? If I have parallel lines, then I know my same side interior angles are supplementary. That is that theorem, right? If I have parallel lines, then my same side interior angles are supplementary. That's the same side interior angles theorem. So I'm going to use that theorem and say I have parallel lines, so these angles that are same side interior are supplementary. Angle 3 and angle 5 are supplementary. Not going to fit. That's okay. Okay? And how did I know I could write that? Because if I have parallel lines, then my same side interior angles are supplementary. That is the same side interior angles theorem. Okay? Remember, the converse is used to prove I have parallel. I'm not trying to prove I have parallel. They already told me I have parallel, right? So I'm using the theorem. Okay? So now, finally, because I know I have supplementary angles, I know by the definition of supplementary, that means they add together to make 180. So I still can't add these two together, though. I have to add the angles together. The measure of angle 3 plus the measure of angle 5, that's what I said are supplementary. They add up to 180. And how did I know that? Because I know what supplementary means. I know what the definition of supplementary is. You're probably at this point thinking the same thing I would be thinking. Can we just write the equation already? Yes, we can. Because now we can substitute what the measure of angle 3 equals, and we can substitute what the measure of angle 5 equals. So I can do, the measure of angle 3 is 7x minus 32, plus the measure of angle 5 is 3x plus 12, and that equals 180. And what did I do? I substituted in for the angles. So substitution, property of equality. Remember, if you're going to abbreviate, make sure I can tell the difference between your substitution and subtraction. Okay? All right, so now I want to combine all those like terms on the left because I can put together my 7x and my 3x. And I can put together my minus 32 and my plus 12. That's going to give me a minus 20. I combined my like terms. Okay, now I want to get that 10x by itself, so I'm going to add the 20 to both sides. Addition, property of equality. When I add the 20 here, that becomes a 0, so I have just 10x. And when I add the 20 here, I get 200. I added to both sides, so that's not combining like terms, it's the addition, property of equality. Okay, we're almost done. Divide both sides by 10, right? So I can figure out what x is. If I divide both sides by 10, x equals 10 divided by 10 is just 1. 200 divided by 10 is 20. Division, property of equality. Okay, and then, let's see, am I done? Did I prove what I wanted to prove? I wanted to prove that, I wanted to prove the measure of angle 5 equals 72. So I'm not quite done yet. I know the measure of angle 5 equals, in my proof, 3x minus 12. But now I know what x is. So I can plug it in to 3x plus 12. So the measure of angle 5 equals 3 times x plus 12. And what did I do? I substituted the x with the 20. So substitution, property of equality. And then last thing, I just have to simplify that little not even algebraic expression, it's just a math expression, right? I just have to simplify that. 3 times 20 is 6, and 6 plus 12 is 72. So the measure of angle 5 equals 72. Now, here's where I want to yell at some of you. If you're in the room and I didn't have to social distance, I might want to like grab you and shake you. Some of you are still putting the word prove here, or prove, or proven, or some sort of form. That's always going to be an option on a drop-down menu or a multiple choice. It's always going to be an option. It's never going to be right. Even though it says prove right here, that is not how I got this last answer. I didn't do it by proof. This whole thing, all of this, is the proof, right? How did I get from this step to this step? I simplified this math. So right here, simplify. Anytime you do this multiplication or simple addition or something like that, it is simplify. Okay? Simplify. Not ever prove. Okay? All right, we have one more proof we're going to look at so you can see how to use the converse in a proof, because this one used the theorem in a proof, right? We want to see how to use the converse also. So here is this one. Thank you so much for watching. There is one more to go. I'll see you later.